Okay, and here we go for problem number 10. So a bus is moving at 24 meters per second. When the driver steps on the brakes and brings the bus to a stop in 3 seconds, what is the average acceleration of the bus while braking? Okay, so yeah, this bus is just kind of slowing down. Brings the bus to a stop. Okay, so hey, you know what? It's going a certain speed. The bus driver is slamming on the brakes and brings the bus to a stop. That's the situation, right? Okay, so let's think about this. What is the initial position? Hey, you know what? Nothing's specifically given to us, so we're just going to say it's 0. What does this 24 meters per second represent? What is that telling us? Okay, so hopefully you're saying to yourself that this is our initial velocity, the 24 meters per second. When the driver steps on the brakes and brings the bus to a stop. So it brings the bus to a stop. What is that telling us? That should be telling us that the final velocity is equal to 0. Time span of 3 seconds. What is the average acceleration of the bus? Okay, so that's simple enough, very straightforward. And it says nothing about the final position, and that's going to be the variable that we simply just don't care about. Okay, so coming back over here. So xf is the variable that we don't care about. Let's go through here. Once again, we're not dealing with our average velocity, so we're coming down through here, looking at these over here. So xf, we're looking for xf. Oh, we don't have xf over here. That's a good potential candidate right there. All right, we do have xf over here, and we simply do see we have xf over here. These are not going to be for us. And coming through over here, we have, oh, there's xf right there. So we're not interested in those. How about that? All right, so it's just our very first formula that we initially suspected that it would be. So let's just write that down. So we have Vf is equal to Vi plus our acceleration times our delta t. Let's plug in and go from there. So our Vf, Vi, our acceleration times 3. Okay, so we're just going to have to solve for acceleration. So we do have 2 terms here. We have 1 term over here, which is just the 24, and our second term is going to be our a times 3. Once again, terms are separated by plus signs and minus signs. You might actually remember hearing about terms when you say to yourself, hey, you know what, let's group up the like terms. So if we actually have our 2x plus 5x, hey, you know what, are these like terms? Yes, they are. So once again, terms are separated by plus signs and minus signs. So our a is what we need to isolate. And let's just get rid of our first term over here. Let's get rid of this positive 24. How do we get rid of a positive 24? Simply by subtracting 24 on both sides of the equation. And that will give us this. And how do we get rid of this multiplication of 3? Simply divide both sides by 3, and we will get our negative 8 meters per second squared, and that's equal to our acceleration, which is the answer that we get right there. I've got one more question for you about this problem. Why is the answer negative? Why is it negative 8 meters per second squared? Why isn't it 8 meters per second squared? Why is it negative? And don't tell me it's because this is negative right here. Okay, so the reason why it's negative is simply because it's a deceleration. Hey, you know what? Aren't we braking right now? Isn't this actually coming to a stop? So we are describing it's not accelerating, it's decelerating. Hey, you know what? That minus sign just represents a negative acceleration, or aka a deceleration.